Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 1 of 21. Your standard Python script runs perfectly in testing, but the moment your dataset hits 50 gigabytes, it crashes with an out-of-memory error. You have hit the physical limits of a single machine. The solution to this bottleneck is the focus of this episode, the big data problem and PySpark's promise. Standard Python data tools are built for single-node execution. Libraries like Pandas are incredibly efficient, but they require the entire dataset to reside in local memory. If your server has 16 gigabytes of RAM and you try to load 50 gigabytes of application logs, the operating system intervenes and kills the process. Scaling vertically by renting a larger, more expensive server only delays the inevitable. Data grows faster than hardware upgrades. Eventually, the data outgrows the box. PySpark solves this limitation. It is the Python API for Apache Spark. Apache Spark itself is a distributed computing engine that runs on the Java virtual machine. PySpark acts as a bridge, allowing you to write your logic purely in Python while taking advantage of Spark's highly optimized distributed engine. This shifts your architecture from vertical scaling to horizontal scaling. Instead of relying on one massive machine, PySpark partitions your data and distributes your computations across a cluster of many smaller machines, known as nodes. You write your Python code, and PySpark translates it into a parallel execution plan. If your data volume doubles next month, you do not have to rewrite a single line of code. You simply add more nodes to the cluster. The PySpark ecosystem is organized into a few core modules designed for different workloads. First is Spark SQL. This is the foundation for most modern PySpark applications. It provides a tabular structure for handling tabular data spread across multiple machines. It also allows you to run standard SQL queries directly against these distributed datasets. Next is structured streaming. This module handles real-time data pipelines. Instead of processing a massive batch of data overnight, structured streaming continuously processes flows of records, like live sensor readings or web traffic events. It uses the exact same programming model as Spark SQL, meaning your batch processing logic and streaming logic look nearly identical. Then there's MLlib, the machine learning library. Training models on massive datasets on a single machine is a notorious bottleneck. MLlib provides distributed machine learning algorithms for tasks like classification, regression, and clustering. It spreads the heavy mathematical operations across the entire cluster, drastically reducing training time. Here's the key insight. The true power of PySpark is abstraction. You never manually slice your massive files into chunks. You never write networking code to coordinate the servers. You simply define a logical sequence of transformations, and the underlying engine handles the data distribution, the parallel execution, and even the recovery process if a node loses power mid-calculation. PySpark is not merely a utility for opening larger files. It is a fundamental shift from computing constrained by a single motherboard to computing constrained only by the size of your cluster. If you find these episodes helpful and want to support the show, you can search for Dev Stories EU on Patreon. That's all for this one. Thanks for listening and keep building.